So it says, for number one, it says complex numbers are added slash substituted. Oh, let's just say subtracted. That's embarrassing. By combining like terms. Okay. Real numbers get added to real numbers, and imaginary numbers get added to imaginary numbers. Okay. This is really similar to the warm-up we did. We just combined like terms. So I have some examples right here that I want you to work on, where all you're doing is combining like terms. If you got the warm-up wrong, hopefully you get these right. Okay. So this first one, it says 3 plus 7i minus 1 plus 2i. So first thing I'm going to do for this problem is I am going to distribute this negative. Okay. So I'm going to distribute the negative to this 1, and then to the 2i. Okay, so we're going to do that first. So you're going to end up with 3 plus 7i minus 1 minus 2i. Okay, from here, I'm going to combine like terms, which is this 3 and this negative 1. That's going to be 2. Then I'm going to combine the 7i and the minus 2i to get 5i. And then you have your answer. This is the final answer here. By the way, the easiest one is adding and subtracting. When we get to dividing, it's the hardest one. So if you're like, this is so easy, it does get harder. Okay, let's do the next one. So we got 3 plus 5i plus 4 minus 3i. Okay, again, we're combining like terms. The 3 and the 4 combine to get 7. The 5i and the negative 3i combine to get 2i, and you have the final answer here. All right, now we're going on to multiplying complex numbers. It says complex numbers can be multiplied using binomial multiplication. It says using a grid to multiply complex numbers can be extremely helpful. So we are going to do this using a grid. If you have not done it this way, that's fine. You don't have to do it this way. I highly advise it, though, because it just keeps everything super organized. Okay, but again, some people just don't like doing it because they don't like showing work this way. They have their own little method, so that's fine. So you do not have to do it this way. I'm just going to show you the way I would suggest, because it's just really good to be organized this way. So what I'm going to do is I'm going to take the 3 plus 2i, and I'm going to take the 1 plus 7i, and basically make a square, or I should say a rectangle. Oops, that's embarrassing. There we go. Okay, and I'm going to grid out so it separates each of the terms. And if you've seen this before, then you know what I'm talking about. So from here, we're going to multiply where these numbers meet. So the 3 and the 1, you multiply those together and you get 3. Okay. The 2i and the 1 make 2i. The 3 and the 7i make 21i. The 2i and the 7i make 14i squared. Okay. So this means that what you can do is when you multiply these together, you can get 3 plus 2i plus 21i plus 14i squared. Now, if you notice, we have to do some combining of like terms because we're adding. That's why we went over adding in the previous part. You end up with 3 plus 23i. I wrote 21 for some reason. 23i. Now, but I squared is equal to negative 1. Another way of looking at it is I is equal to the square root of negative 1. So if you square both sides, squared and squared, this squared and this square root cancel, and you get I squared is equal to negative 1. Okay. Let's keep going now. We have 3 plus 23i minus 14. We can combine like terms on this. So we have 3 and negative 14. That's negative 11. plus 23i. And this would be your final answer. Now that's a lot of work for one little problem. So I highly advise, since it's a lot of work, there's a lot of room for error, I highly advise checking this on your calculator. So that's what I'm going to do now. So everyone take your calculator out. What we're going to do is we're going to do 3 plus 2i. And if you remember, the I is in if you hit second decimal point. That's how you get the I. If you remember, second decimal place. Okay, and then we're going to multiply this by 1 plus 7i. I do need to make sure that this is actually the right one. 3 plus 2. Okay, and then all I have to do is hit enter, and it spits out hopefully the exact same answer we got. Okay, again, you can use your calculator, but you still have to show work. So if you just write the answer down, I'm going to know you did something. You just kind of use the calculator, not showed work. So easiest way to show work, in my opinion, is use the grid method. So we have 1 plus I quantity squared, which is really just 1 plus I times 1 plus I. So what I'm going to do for this is use the grid method again. So we have 1 plus I. And then we have 1 plus I. All right, so you're going to have 1, you're going to have I, you're going to have I, and you're going to have I squared. So if you rewrote this, it'd be 1 plus I plus I plus I squared is -1. I'm just going to put -1 in there. The -1 and +1 cancel, and you're left with 2i. Okay, so the next thing we need to do is actually check this on our calculator. So on your calculator, do 1 plus I quantity squared. 1 plus I quantity squared, and you get 2i. Let's go on to the last thing that we're talking about today, dividing complex numbers. Okay, so it says dividing complex numbers can be the most difficult of all the operations because there are certain simplification rules that come into play. In order for a complex number to be completely simplified, I cannot be in the denominator. Okay, for whatever reason, some math rule is you can't have I on the bottom. Kind of like you can't have the square root on the bottom. Okay, don't ask me why, I don't make the rules, but that's the way it is. You cannot have I on the bottom. So the way of getting rid of I, one way, is multiplying by I over I. Okay, that's one way. Another way is if you use conjugates, something that's called conjugates. And I always think of conjugates as good twin, evil twin. And what I mean by that is A plus B and A minus B, for all intents and purposes, they're the same except for the operation in the middle is different. So A plus B, A minus B, one's positive, one's negative, so that's good twin and evil twin. When we went over the unit last week, I kind of mentioned this. So if you're like, you already said this, it's because we're going like deeper into this understanding of it. So hopefully it makes more sense when we do these example problems below on dealing with dividing complex numbers. So here we go. So this first one, it says 3 over 2i. You cannot have I on the bottom. Okay, so it says 3 over 2i. So it says right here, just multiply it by I over I. So that's what I'm going to do. I'm going to multiply this by I over I. And if you do this, you will not have an I on the bottom anymore. And I'm going to show you why in a little bit, in 1 second here. So we have 3i if we multiply across. So I just basically took this and multiplied it to get that. I'm going to try to color code everything here. On the bottom, you're going to have 2i times I, which is just 2i squared. Zoom in so you can see it. You have 2i squared. Well, I squared is equal to what? Everybody in unison? -1. Not bad. We'll work on that. So you're going to have 3i over -2, essentially, because it's going to be 2 times -1. excuse me, which is going to be equal to 3i over -2, and then that's your final answer. Now you might be thinking, whoa, that's pretty cool. Wouldn't it be awesome if we can do it on your calculator? This is the one thing that you cannot do on your calculator. Okay? I'm just kidding. Your calculator does this. It's pretty awesome. Check this out. Ready? 3 divided by 2i. Make sure the 2i is in parentheses, and watch this. It even puts it in the numerator for you. Here, let's do this. Let's do math frac on this. Look at that. -3 over 2 pi, which is exactly what we, which is exactly what we got right here. Okay. It is really important to understand you have to use parentheses on the denominator for these. If you do not want to use parentheses, if you have a TI-84, you could throw this in your calculator this way. Watch this. Hit alpha y equals and hit n over d. It says numerator over denominator right here. And it makes a fraction for you, so you never have to use parentheses. You can just do 3 and then 2i, and then you just hit enter. And it does all the work for you. It really helps because some people will do this. They'll do 3 divided by 2i, but really what this is it's 3 divided by 2 and then times I rather than dividing by the I. So that's the wrong answer. That is not the right answer. This -3 over 2i is the correct answer. Okay, because you have to use parentheses. It has to be 3 divided by 2i, or you can use the fraction thing, which is easier. There is a difference between those two. And it is similar to if I did something like this, 1 over 2 times 2. That is different than 1 over 2 times 2 in parentheses. Okay. Parentheses matter. These are the easiest ones where it's just an I on the bottom. The hardest ones are like B, where it says like 4 minus 5i on the bottom. That's where we have to use what's called a conjugate. So definitely make sure you pay attention to this. So you have the problem like this. You can't just multiply the top and the bottom by I because it's not going to work. So by the top and the bottom by is the conjugate of whatever's on the bottom. So that's a -5i. We're going to do a positive. So 4 plus 5i. So this is where I'm talking about good twin, evil twin. Everything's the same except for what changes is the plus and the minus. Yeah, so what I want you to do actually is grid that out. We'll reconvene. So take a couple minutes to kind of do this on your own. And then when you're done, compare it to what I get. All right, so that first one, the numerator, if you actually work everything out here, it's going to be 8 plus 12i plus 10i, that's 22i, plus 15i squared. Well, I squared is -1, so this is technically minus 15 here. So you end up with -7 plus 22i, which is what I have up here. Now it says -20i and 20i. So what's awesome about that is this and this just straight up cancel. That's always going to happen when you do good twin, evil twin. The middle term will cancel. So then you're left with 25 minus 25i squared. Well, 25i squared is -25, but there's a negative, so it's really plus 25, right, Scott? Yeah. And you end up with 41, Scott? Yeah. Okay, cool. So now what's cool about this is you can also do this entire thing in your calculator. You still have to show work again for full credit. Okay, the next one. Oh wait, let's do it in our calculator really quick, just to kind of show you. So we're gonna do alpha y equals numerator over denominator, and we're going to do, was it 2? Yeah, 2 plus 3i over 4, was it minus 5i? I was just lazy and did 2, 3, 4, 5. I didn't feel like thinking of numbers. And check that out. It breaks it down just like what we have. It for whatever reason, it divides up the denominator there. It's the same thing as what we have. If you wrote it like the calculator, I'd be fine with it. If you wrote it like I did it, I'd be fine with it. I don't care. It means the same thing. Okay. All right, we got one more, and then you have the rest of the time to work on whatever you want to work on. So I want everyone to work on part C, and then check it in your calculator, and then you'll know if you got it right or wrong. It's almost like your calculator is an answer key. In a way. All right, there is all the steps for that problem right there.